I want to give you a little bit more insight into the shellcode. So we've got a shellcode investigation demonstration that I'm going to compare two different Windows shellcodes, both from Metasploit, and we'll see that they can vary, both generated by different versions of MSF payload. As I said, that's changed a lot throughout the years, and that's something that if your shellcode's not working, investigating it in this way might help you understand why. All right, so I have our shellcode. We'll just pop that up, and it's just in a Python file here. We can use this Python script to output it to a bin file if we wanted to investigate it that way. Or if you put it in a C file, you can compile it into an executable, and then the demo version of IDA will allow you to examine either a Windows PE or a Linux ELF. It doesn't actually let you examine a .bin file with the demo version. You'd have to have a full paid version to be able to do that. So having these compiled, we can take one of those shellcodes, drop it on IDA, open it up. Yep, go ahead and hit OK through that. It was compiled with debug symbol, so it asked us about that. And we can see that all that C program did was basically print out shellcode it is and then run the actual shellcode. So if we double click on this, this will take us to a reference into the data section, and here we see the bytes of the shellcode. And it's not very helpful to view it as data bytes, so we really want to view it as code, and you can do that in IDA just by hitting the letter C on your keyboard, and it'll say, do you really want to convert that to code? Yes, I do. And now we see, lo and behold, we have it in code, and we can click on this call to this part of the shellcode down here, which, as I said, there's the pib setup and the hashes of those functions. But the question is, what functions are going to be called? I mean, we kind of know that it's going to run calc. That's what the shellcode's supposed to do. That's what we told MSF payload we wanted to do in our command to it. But really, we need a little deeper insight. We either need to trace through all this assembly one at a time, or maybe at least figure out which functions these hashes resolve to. And that's what I wanted to show you how to do, a simple thing that we can do to do that. So we go over to our command shell here, go into the shellcode of this lab, and I have a Python script here called export hashes to IDC. And what that Python does is it converts or creates a mapping between a particular DLL. So let's do Windows system32 kernel 32.dll. And when we do that, it creates a file called kernel32.idc. And we can go and have a look at either of those if we want to understand how the hashing works. We can look through this. We're not going to take a lot of time to do that. Or if we wanted to look at what this IDC is, we'll basically see that it creates a mapping between a hash value and the actual name of the function. And what's cool about that is now we can go back to IDA, and we can go File, Script File, kernel32.idc, run that. It'll take a second to run. It'll basically build a name map in memory, and then we can cursor over those hashes once it's done and hit the M button, and that'll tell us what this does. This does exit thread, and this does winexec, and winexec is what calls calc. Okay, cool. That's really awesome. That gives us a much better insight into what this shellcode does. So let's take a look. I had two different ones. I had this one, shellcode 1, both generated by Metasploit, and I also had shellcode 2, also generated by Metasploit, a slightly newer version of Metasploit. They're both compiled, so let me throw that into IDA and see, does it create the same shellcode? It should, really, you think it would, unless something's changed as far as how that needs to work over the years. So let me hit C like before, and then we'll go down to these hashes like before, and we need to do the same thing. Script file, load this kernel32.idc, open that up. Takes a second to run, and then we can again just hit the M button on your keyboard to create a name for this. Well, this is winexec, just like before. That makes sense. And this is actually something different. Set unhandled exception filter. Interesting. And we'd have to dig into what MSF payload is doing there and why it created a slightly different ending. So basically, this is how you're going to end your shellcode, either by exiting the thread, or in this case, by set unhandled exception filter. And that may help us understand, well, let's say that one of those two shellcodes is working on one particular version of Windows, but the other isn't, or vice versa. Understanding those types of things will give us deeper insights into our shellcode. And so that's really what I wanted to show you, how to begin an investigation into creating and debugging shellcode.